And Assalamualaikum. Okay, so this is a video for the lecture for the topic of differentiation. Okay, so before we start through the topic, I'll give you some context about differentiation. Okay, so basically, if differentiation actually tells you how fast something is changing. How fast something is changing. Okay, I give you an example. Yeah, let's say you are walking along a path. So you have a path and then you're walking on the path. From your view, the path actually show you a distance as you're moving over the time. So when you're moving, so you're gonna see how far the path is. What is the distance of the path? Okay, but then for differentiation, right, it tells you how fast your distance is changing when you moving forward. So they tell you how fast your distance is changing. So basically differentiation is telling you how fast something is changing. So when we talk about differentiation, right, so we usually are using, or we are actually handling a function or equation. So usually an equation in mathematics we used to represent by using fx or y, correct? So if we want to do differentiation of a function or of an equation, okay, so from fx it becomes f prime x, okay, or from y we can use dy dx. So this is what we call it as differentiation. Okay, you have the prime on top, or if you use y as your equation or function, you just have to change it. When you differentiate it, it becomes dy dx. Remember, yeah, fx, when we differentiate, it become f prime x. So the one that is on top, the apostrophe, is the prime, f prime x. And then if you have y, and then if you want to change or you want to differentiate it, you're gonna get dy dx. Okay, so for this topic, what you guys will learn is apply the power rule to solve differentiation problem, determine the gradient of a tangent or a normal to any point on a curve through the concept of differentiation, and then set up the equation of tangent or equation of normal to any point on the curve and determine the turning and inflection point of a curve. Okay, now before we start to go through learn all of that, you have to learn the rules of differentiation also. Okay, just like how we learn the rules of logarithm and index, okay, we also have the rules for differentiation. Okay, we have a few. The first one is constant rule. So let's say if you have y equal to c. So what is c here? C is a constant. What is a constant? A number. Let's say I give you 12, or I have -4, or I have 1/2. All of these are actually a constant where we represent with c. And then when you want to differentiate a constant, okay, it will be 0. Okay, you can represent using f prime x equal to 0 or dy dx equal to 0 if your equation is y. Okay, if your equation is fx, then you will change it to it. When you differentiate, become f prime x equal to 0. Now we go through example. Yeah, fx equal to 8. When we differentiate, remember 8 is a constant, right? So it becomes f prime x equal to 0. Now we have 7.398. fx equal to 7.398. It's still a constant, right? So basically when you differentiate it, it becomes 0. Okay, so this is the first rule. Second rule, we have constant multiple rule, where here we have fx equal to mx. Then when we differentiate it, become m. Okay, so remember, yeah, you have a function fx is equal to mx. So basically m is any constant that you can have. Okay, any constant. X is a variable. Okay, so when you differentiate it, if you see here, x here, right, it is x to the power of 1. So by right, it's only x lah. Okay, so when it's only x, when you differentiate it, become m. Okay, so we go through the example. We have fx equal to 7x. So 7 here is your m actually. Okay, so when we differentiate it, it becomes f prime x is equal to 7. You remove the x here. It only works when you have x here. Okay, it is not x to the power of 2, x to the power of 3. No, it's only for x to the power of 1 or x. Now we go through question B. Fx is equal to negative 5 over 17x. So we have to find the differentiation also, right? So f prime x equal to negative 5 over 17. X, do we have to put? No need, because this rule, when we differentiate, just copy the constant, only take the constants. Okay, now we go through the next rule where we have power rule. Okay, so for this guy, we have a power rule. Fx is equal to x to the power of n, and when we differentiate it, we will get this guy, n x to the power of n minus 1. So how to do this one? To make it easier for you, yeah? So let's say if you have, let's say if you have fx is equal to x to the power of n. So what you guys have to do is, when you want to find the differentiation, here you see the power on top, you bring in front, become n. X you copy, to the power of n you copy, the power you put minus 1. That is how you have to do for this rule, for power rule. So we go to example, yeah. Calculate f prime x if fx is equal to 9x to the power of 4. Here it got power, x to the power of 4. So what you guys have to do is copy first we have f prime x equal to the power here you bring in front 4, then 9 you copy, multiply by 9, then x to the power of 4 you copy, and then put minus 1. Then here it become 4 multiplied by 9 is equal to 36, and then x to the power of 4 minus 1 become x to the power of 3. So this is how you do for power rule. Okay, now to make it to make you understand more, we go through a second example where we have fx is equal to negative 5 x to the power of 6. So here, even though in front we got negative, still the same, where you just put f prime x first, then you see got 6 here, right? You bring in front 6, you bring in front, and then we have negative 5, copy negative 5, and then we have x to the power of 6, you copy first, and then the power you minus 1, and then here you settle 6 multiplied with negative 5 become negative 30 x to the power of 5. So that's it for power rule. Easy, right? Okay, now we go through sum rule. Sum rule actually similar with the power rule, it's just that we have more than one term. If you see from the first rule, second rule, the third rule that we learned just now, it only has one term. Now for sum rule, we have more than one term inside. Also the same, we just have to differentiate using the 3 rules that we learned just now. Okay, so here we have we just straight away go to the example. We have fx is equal to 8 plus 8x to the power of 2 plus 3x to the power of 3. So how to solve this question? Okay, we have 8, right? So follow our first constant rule. 8 is a constant. When we differentiate, become 0. So 0 plus with 8x to the power of 2 is what, like? If you see x to the power of 2 is power, right? It's a power rule. So we use power rule. Then you bring 2 in front. So you put 2. Multiply with 8. And then x to the power of 2 you copy. Then power we minus 1. Then we settle for 3x to the power of 3. Also the same here. You put plus. Okay. Bring in front 3. So 3 multiply with 3. Then copy x to the power of 3. Then the power minus 1. Then when we got like this, right, you just simplify. Then 0, you just maintain, no need to put 0. 2 multiplied by 8 is 16. Then x to the power of 2 minus 1 become 1. So no need to put x to the power of 1. And then we have 3 multiplied by 3, which is 9. X to the power of 3 minus 1 become x to the power of 2. So the answer is 16x plus 9x squared. That's it. So now we go through question B, which is similar also. This time it has more than one term, which is that they have plus. It can be minus as well. Yeah? It can be minus here. So it's the same lah. Okay, now we find the answer for 10x to the power of 5 plus 6. Then here 10x to the power of 5, we can use power rule. So you bring 5 in front. So 5 multiplied by 10. Multiply with x to the power of 5, we copy the power minus 1. And then we settle already this term, settle for 6. So plus with 6 when we want to do 6. 6 is a constant, right? So a constant when we differentiate becomes 0. Then the final answer is 5 multiplied by 10 is 50. X to the power of 5 minus 1. 5 minus 1 become 4. So this is the answer. That's it for some rules. So this is the few rules that you guys have to understand and understand for this for this semester syllabus. Actually, we have a few more, but to make it easier for you to understand, or for your syllabus this semester, only up to these 4 rules that you guys have to know. Okay, and then now we will go through another topic under differentiation as well, because you have to use the concept of differentiation, which is related to tangent. Okay, basically what is tangent? Okay, tangent is actually a straight line that just touch the curve at a point. Okay, it has the same slope as the curve there. So you know what is curve, right? In our, let's say in our graph, we have a different type of graph. It can be quadratic, so it can be cubic. So it is actually a curve, correct? Okay, so this tangent is actually a straight line that touch the curve at the point. So let's say if I have a curve like this, okay, and then now I have a straight line that touch any point. Let's say I have a point here, and I touch like this. So this guy, the blue guy here, is actually a tangent. It can be here as well, tangent also. Yeah. Can be tangent, but it must touch the curve here. Okay, so it must touch the curve, then it has a straight line like that. Okay, so that is a tangent. Doesn't matter where is the curve, as long as at this curve it has a point, right? And then you have a straight line that touch this point, then it is called as a tangent. Okay, and then this tangent, right, it has the same slope as the curve there. So remember, I don't know whether you guys understand or not what is slope. So slope is basically gradient. So we learned already gradient before this, right? Okay, slope means gradient. So when we have a tangent, this tangent is actually has the same gradient as your curve. Okay, now when you have a tangent, see, this is your tangent. When you have a tangent on a curve, by right you also have a normal. Okay, this guy we call it as normal. This normal, how to identify it? It is actually a right angle or a line that is perpendicular to the tangent line just now. So this one is a tangent line, right? So another line that is perpendicular to this tangent line, we call it as normal. That's why I put a right angle here lor. Okay, so basically here we have a point xy. So that's why here we have the green color, which is a tangent, and then when it is perpendicular, we have a normal. Okay, so now we will learn how to find equation of a tangent line, and we have to go through also equation of a normal line. So first of all, for equation of a tangent line, so basically if you check the tangent line, it is a straight line, right? Okay, so since the tangent is a straight line, so basically it is a linear line, just like how we have y equal to mx plus c. Okay, so in order for us to get the equation of the tangent line, okay, a straight line that we have before this, when we learn about linear equation, when we want to find the equation of the straight line, we have to use y equal to mx plus c, right? Or we also have y minus y1 equal to m multiplied with x minus x1 to get equation of straight line. But now in order for us to get the equation of the tangent line, so we actually can use the same formula here. Okay, y minus y1 equal to m multiply x minus x1, but then you have to use this formula where you guys have to change the one that is in the middle, change to the gradient there, you have to change to the gradient of tangent, mt. Okay, you have to change to gradient of tangent. And then at the end, from this equation, when you substitute x1, you substitute y1, you substitute mt, okay, you have to form y equal to mx plus c. So that is the tangent, equation of tangent. So now when you see mt, right, how to get this mt, which is the gradient of tangent, you have to use this formula. Oh, sorry. Which is mt equal to dy dx, and then we substitute x1 inside dy dx. So what is dy dx? Differentiation lah. And what you have to do is, first of all, you have equation, right? You have a function, and then you differentiate the function. After you differentiate the function, and then you have to substitute a point, which is a point of x, inside the equation after differentiate just now. After differentiate, then you substitute the value of x, and then you will get the mt. Okay, so basically this mt is actually the gradient of tangent. Then x1 and y1 is the point here, a point that touch the tangent line. Okay, now once you get that one, okay, we have to go through the next one where we also can find the gradient of normal of your point just now. So we have a tangent, correct? Where sorry, we have a tangent, right? Let's say here is a point, but then here we have a normal. So how to get, let's say we already got mt, so how to get this gradient of normal, which is mn? Remember that this guy is perpendicular, so when it is perpendicular, we actually can use mt multiply with mn equal to -1 because it is perpendicular. So let's say we already have mt, so if you want to find mn, what you guys have to do is you have to bring mt to the right side, so -1 over mt. So this is how you actually can get mt. How to get this is how you can get mn. So how to get mt? Using dy dx, and then you substitute x1 inside x after you differentiate. Okay, and then what you guys have to do is use -1 over mt, then you get mn, gradient normal. So why do we need to find the gradient normal at a point? It is because question can ask you to find the equation of normal line. Just now we learned about on how to find equation of tangent line, right? But then inside your question, your exam paper, all right, they might as well ask you how to find the equation of a normal line. So how to find the equation normal line? Okay, almost similar like tangent just now, where we have y minus y1 equal to mt multiplied with x minus x1. So what you guys have to do is just replace mt with mn. Okay, and then you will get the answer. So how to get this mn? Using this one lah, -1 over mt. Okay, how to get mt? Using dy dx. You find dy dx and then substitute x1 inside x inside the dy dx just now. Okay, so from here you can see, right, the important thing that you guys have to find here, you guys have to understand is this form of formula for tangent, equation of tangent and normal, where you have to remember this formula and then replace m inside with mt or mn. Okay, when they ask you to find equation of normal, after you substitute inside all the value, at the end you must form this equation, y equal to mx plus c. So you have to expand properly lah. Okay, so to make it easier for you, right? So instead of just explaining you like this, better I explain and we go through question together so that you guys can understand properly. Okay, so now we have a question: determine the gradient of tangent to the curve y equal to 2x square at the point 1, 2. Determine the gradient of tangent. They want gradient of tangent. It means we want mt to the curve y equal to 2x square at the point 1, 2. So when we have this kind of question, right, one thing you have to remember is we extract all the information first. So we have y equal to 2x square, correct? We also have point 1, 2. So this point 1, 2 is your x1, y1. This is your y. Right now, we want to find mt. So you have to remember here the formula of mt is dy dx, and then we have to substitute x1 inside. Remember, find dy dx first. So the first step is find dy dx. So how to find dy dx from what? From equation y that we have here. So we have y equal to 2x square, correct? Y equal to 2x square. To find differentiation of the y just now, a. So to find dy dx, we have 2x square. 2x square is actually x square is a power, right? So we can use power rule to differentiate this. So you bring 2 in front. Okay, then you're gonna get 2 multiplied by 2, and then x square we copy, the power we minus 1. So you're gonna get 4, 2 times 2, 4, and then x2 minus 1 become x to the power of 1. So here we don't really put x to the power of 1, but we just remove like this. Okay, so you got already your dy dx. Now what you guys have to do is, second step, using the point that you guys have here, using 0.12, you substitute the value of x. So where is your x1? This guy. Okay, you substitute x is equal to 1, into the dy dx that you got just now. Okay, so you substitute dy dx. So basically you will get the mt, which is, you have your dy dx, right? Dy dx, substitute x, x is equal to x1. So you have your dy dx, which is 4x. So 4x, you substitute inside x, which is x is equal to 1. So you're gonna get 4. So basically your mt, gradient of tangent, is equal to 4. That's it for you to find the gradient of tangent. Easy job this one. Okay, remember, find dy dx, and then you substitute the value of x inside the dy dx. That is how you find the gradient of tangent. Now we go through the question 2. Okay, this question they ask you to construct the equation of tangent into the curve y equal to x squared plus 3x plus 1 at the point 0, 1. So when we have this kind of question, right, so remember to extract all of the information. So this guy is your y, 0, 1 is your point x1 and y1. Okay, when they want equation of tangent, so by right they want y minus y1 equal to mt, because equation of tangent, so x minus x1. So here if you see we have mt, right? So how to find mt? Remember, it is dy dx, and then substitute the value of x1 inside. Now, do we have mt? No, we don't have. So that's why we have to find mt first. Okay, to find mt, find dy dx, which is, you're gonna get y is equal to x squared plus 3x plus 1, correct? But then here, so we have to differentiate lah. Find dy dx. So x square, you're gonna get, you bring 2 in front, you're gonna get 2x, the power become 2 minus 1, plus with 3x, we differentiate. This is a constant power rule, right? This is constant multiple rule. So we have 3x, when we differentiate become 3. Then plus with 1, we differentiate become 0. So the final answer here become 2x to the power of 1, so 2x, plus with 3. So this guy is your dy dx. Okay, so this is the first step. Second step, what you guys have to do, use the point 0, 1. Then you're gonna get x1 is equal to 0, correct? Then substitute inside dy dx. So then you will get empty. So to find empty, you get your dy dx already, right? 2x plus 3. So substitute inside x here. This one, you substitute x is equal to 0 from this, from the point. 2 times 0 plus with 3, you're gonna get equal to 3. So this is your empty. This is your empty. Now we just got the value of empty. What you guys have to do is, our final answer, they don't want equation, they don't want the gradient of tangent, they want equation of tangent. So what you guys have to do is substitute inside the formula that we have on top here, okay, which is y minus y1 equal to empty x minus x1. Okay, but now substitute inside x1 and y1. So we have y, you maintain, y1 where to get from the point 0, 1 here. X1 is 0, y1 is 1, right? So y minus 1 equal to empty is equal to 3 that we got from second step just now. X, you just maintain. X1, you copy 0, put inside, substitute 0. Then here, you expand properly, you're going to get y minus 1 equal to 3. X minus 0, x, huh? Okay, and then you bring negative 1 to the right side. Y equal to 3x plus with 1. So, okay, so this is your final answer. So your y is equal to 3x plus 1, which is also similar with the form of 3mx plus c, bah? So this is what you want lah at the final answer for equation of tangent. Okay, so now we proceed to the next one, which is question 3. We have set up the equation of normal to the curve. Normal up to the curve, where we have y equal to x squared plus 4 and then the point of 1, 1. So from this we know that this is our y, x squared plus 4x minus 4, and then 1, 1 is our x1 and y1. Equation of normal, the formula will be y minus y1 equal to mn multiplied with x minus x1. Okay, now the first step here is, since we want equation of normal, of course we must have mn, correct? So how to find mn? Remember the formula of mn, it is negative 1 over mt. But then do we have mt? No, we don't have. So how to find mt? The first step is find dy dx, which is, we have y, right? Equal to x squared plus 4x, plus 4x minus 4. Then you differentiate this guy, you will get x squared become 2x, 4x become 4, minus 4 become, negative 4 become 0. So no need to put lah. Okay, so this is your dy dx. Now, you have point 1, 1. So, second step is, use the point 1, 1 just now. Substitute, you substitute x1 equal to 1, which is, this guy is your x1 bar. Okay, this guy is your x1. Substitute into the dy dx that you have. So your dy dx is 2x plus 4, right? So to find mt, so you have 2 multiply with x, which is x, we have 1, plus with 4, then you're gonna get 2 plus 4 equal to 6. And then mn, here you already got mt, right? Mt is equal to 6. Then how to find mn? Using this formula, negative 1 over mt, which is 6. So this is your mn. Now you already got your mn, so what you guys have to do is substitute inside the formula for equation of normal, which is y minus y1 equal to mn multiply with x minus x1. So y minus y1, y1 is your, y1 is equal to 1, mn is equal to negative 1 over 6, x minus x1 become, x1 become 1. Okay, what you have to do here is expand ja. Okay, y minus 1, negative 1 over 6 multiply with x. Okay, and then negative 1 over 6 multiply with negative 1 become positive 1 over 6. Okay, and then here you have negative 1 at the left side. Then you bring to the right side, you're going to get y equal to negative 1 over 6x plus 1 over 6 plus with 1. Then the final answer you're going to get is negative 1 over 6x plus with 7 over 6. So this is your final answer for this one, which is your equation of normal is y equal to negative 1 over 6x plus 7 over 6. Okay. Okay, now we will go through the subtopic of turning point on a curve. So what is turning point? Basically, a turning point is actually a point on your curve where the function change direction. Okay, from increasing and then suddenly it decrease. From decreasing, suddenly it increase. So where is the turning point? At this one. The point where it decrease to increase or increase to decrease. So that is the turning point here. So at this point, the curve actually turns around. So that is why we call it as turning point. So we call it as turning point or stationary point also can. Okay, so inside your question, sometimes they're going to ask you to find stationary point or they ask you to find turning point. And then at this turning point, right, because it is a point on a curve. So we learned already a point on a curve, when it has a straight line, it is called as a tangent, right? But then when you have a tangent line, or when you have a line, a straight line that touch this turning point or stationary point, the gradient is equal to 0. Mt just now equal to 0. Okay, doesn't matter whether it is here or it's here. Okay, the gradient is equal to 0. Mt is equal to 0 when it is a turning point. Okay, so basically what turning point tells you, they actually describe to you how the curve behave at that particular point. Okay, and then it is actually a stationary point of a curve, and then if we draw the tangent of the curve at stationary points, right, the line are actually parallel to x-axis will be obtained. Okay, and then basically it just tell you that the gradient of the tangent at this point, okay, equal to 0. Just like how I explained to you lah. So easy for you to remember is that mt equal to 0 or dy dx is equal to 0. So that is the gradient of the line at this turning point. Okay, so when they mention turning point, you just remember dy dx is equal to 0. Easy for you, dy dx is equal to 0. Now, the nature of turning point is basically refer to the point whether it is minimum or maximum. So we learned already right before this, when we learn quadratic equation, when it is like this, set graph. Okay, this guy is your maximum point. When we have smile graph, this guy is your minimum point. Okay, maximum, minimum. Okay, also similar with any curve. Usually inside the curve, if you have a few curve or a few turning point, okay, you can see actually whether it is minimum or maximum. So when you check here, right, this is the point where it is increasing, suddenly decrease. So it is maximum point or the turning point lah. And also here we have F, from decreasing suddenly it increase. So this guy is your minimum point. Okay, so at E and at F, this is a local maximum point or max point lah, if you want to make it short form. Okay, F is local minimum point, or you just put minimum point also can. At G also, if you see, it has it suddenly decrease and then increase, right? This is also a point, a turning point, but then inside turning point, it does not only have maximum and minimum, but then it has a point of inflection as well. So G here is actually a point of inflection. So what does it mean by a point of inflection? It is similar as E and F, where it can go up and down, or down and up, or increase to decrease, or decrease to increase, but then it doesn't bend a lot. So if you check here, right, it bends a lot like this. Okay, it is obvious that we can see from increasing to decrease or decrease to increase, but then for point of inflection, it doesn't really show to you. So it just bend a bit here. Okay, so this is what we call it as point of inflection. Okay, it bends, it still bends, but doesn't bending a lot lah. Okay, now how to find whether this turning point is actually local maximum point or local minimum point? Okay, you guys have to do second order derivative test. Okay, just now we before this we learned how to find dy dx, right? Okay, now when we want to determine the nature or the characteristic of turning point that we have, whether it is maximum or minimum point, right? Okay, what you guys have to do is, from this equation that you get, you just have to differentiate another time, one more time, and then we change the symbol, become d square y divide with dx square. Okay, d square y dx square lah. So you differentiate this one more time, and then you substitute sub x1 into the equation that you differentiate 2 times just now. Then you check, after you differentiate, what you're going to get. If it is less than 0, this guy, the point that you have, it is a local maximum point. If after you substitute become greater than 0, your point just now is local minimum point. Okay, local minimum point. So easy for you to understand. We go through example. So determine the nature of turning point for y equal to 3x squared plus 3x minus 5. Okay, how to determine this point, the nature of turning point? If you see here, differentiate 2 times. Okay, so here we have to find the turning point first, because we don't have turning point right now. So you have to find turning point. When they say turning point, you have to find x and y. Then after you get this x and y, you can determine whether it is minimum or maximum. So how to find this turning point? The first step is, okay, first step, you have this, right, which is y is equal to 3x squared plus 3x minus 5. So you guys have to differentiate 1 time first. Okay, y equal to 3x squared plus, this is how to find turning point, yeah? I think I have to write find turning point, because right now they don't give you turning point. So the first step is differentiate one time. Okay, we have y equal to 3x squared plus 3x minus 5. Differentiate one time, you're gonna get dy dx equal to 3x squared, we differentiate become 2, we bring in front, multiply with 3x to the power of 2 minus 1, the power minus 1, and then 3x differentiate become 3 minus 5 differentiate become 0. And the answer here you will get 6x plus with 3. So this is your dy dx. Now to find the point, so once you get dy dx, okay, this is the first, I put a long. Second step is you have to let dy dx equal to 0. You have dy dx equal to 6x plus 3, right? This guy you put equal to 0 and then find the value of x. 6x is equal to negative 3. X is equal to negative 3. 6 you bring to the right side become negative 3 over 6. So x is equal to negative 1 over 2. This is your point x because we want to find xy, right? So right now you just get x. So how to find y? Okay, to find y, you just use the equation y here lor. So next step, step C, find y. How? You have x is equal to negative 1 over 2, right? So when x is equal to negative 1 over 2, okay, y is equal to 3 multiply with negative 1 over 2 squared plus with 3 multiply with negative 1 over 2 minus with 5. Then here you substitute. Okay, you're gonna get, this one you calculate, you're gonna get negative 5, 3 over 4. So you already got y, you already got x, right? So from this, you can form a point which is negative 1 over 2, negative 5, 3 over 4. This is your point right now. So we already got a turning point right now. Now we have to determine the nature because the question asks you to determine the nature, right? So how to determine the nature? In order for you to determine the nature, you have to use this guy, which is we have to differentiate 2 times and then substitute x1 inside. Substitute value of x. So we differentiate 2 times. So just now we differentiate 1 time from this. Okay. Second step, determine the nature. Where you guys have to differentiate 2 times. So you have dy dx equal to 6x plus 3. Differentiate 1 more time, you just have to put square like this. And then how to differentiate? Differentiate 6x plus 3. So 6x we differentiate become 6. Plus 3 become 0 because it's a constant. So right now, what you guys have to do is, the next step, substitute x is equal to negative 1 over 2 into d square y dx square. So right now, your d square y dx square, or after we differentiate 2 times, we got 6, right? So inside this, we don't have x. Okay. So when inside this, when we want to substitute, when x is equal to negative 1 over 2, we want to substitute, right? So by right, we don't have x inside. So here, after we substitute x is equal to x1, it is still equal to 6. Okay, so this is your final answer after you supposed to substitute right? Okay, so you got 6. So you just have to check 6 is greater than 0 or less than 0. It is greater than 0, right? When it is greater than 0, by right, the point that you got just now, which is this point is actually, okay, it is greater than 0, right? Negative 1 over 2, negative 5, 3 over 4 is a minimum point. Like that. That's it. That is how you can get the answer to find the nature of the turning point. So it depends on what value you got after you substitute inside the differentiation of 2 times just now. If it is greater than 0, then it is minimum point lah. Okay, or vice versa. So you have to see lah the situation of the question. Now, the question, okay, other than turning point. So remember when we have inflection point where it is bending a bit just now. Okay, still up and down from increasing to decreasing, but it is bending a bit. Let's say just like this kak. Just like this. Sorry. Like this guy is the turning point. It's just bending a bit. So this is the inflection point right now. To determine the inflection point, okay, or to check whether it is inflection point or not. Okay, so the first step is what you guys have to do. Different from the turning point, you have to differentiate 2 times, right? Okay, you have to differentiate first time to get the point, and then after you get the point, you differentiate second time, and then you can check. For inflection point, you have to differentiate 2 times and then get the point. After that, differentiate one more time, the third time, and then check whether it is equal to 0 or not. Okay, remember first step is differentiate 2 times. And then you let equal to 0. Then find x. Okay, after you find x, then you're going to get y. So you will get a point x and y. Now you have to check whether this point is an inflection point or not. So in order for you to check or determine inflection point or not, you have to differentiate the third time. So we just change d3 d cube y dx cube. You substitute the value of x that you got here. If it is not equal to 0, then it is inflection point. Must make sure that it is not equal to 0. So to make it easier for you, we go through example. Okay, identify the inflection point on the curve y equal to x cubed minus 9x squared minus 21x plus 2. Okay, so for this question, right, see, they want us to identify the inflection points. If you see here, inflection points, it can be more than 1 point. It depends on the question, depend on the equation lah. Okay, so for this one, we don't have the point, right? So we have to find the point first. So the first step, find the point. To identify the point, you have to let differentiate 2 times equal to 0. After that, you find the differentiation first lah. Okay, so we have y is equal to x cubed minus 9x squared minus 21x plus 2. Then here, find dy dx first. Dy dx, 3, bring in front 3x to the power of 2. And then 9x squared, you bring 2 in front, become 18x. 21, negative 21x, if we differentiate, it's not 21, huh? 21x, we differentiate become 21. 2, we differentiate become 0. Now, we differentiate one time already. Differentiate the second time. 3x squared, we bring 2 in front, you're going to get 6x to the power of 1. Negative 18x, we differentiate become negative 18. Negative 21, differentiate become 0. Okay, this is the first step. Second step, you let d square y dx square equal to 0. So 6x minus 18 equal to 0. From this, find the value of x because we want to find the turning point right now. So you move negative 18 to the right side, become 6x equal to 18. X is equal to 18 divided by 6. So the answer is 3. So your x right now is 3. So you got your x. Now we have to find y. So when x is equal to 3, your y equal to what? Where to substitute y? Here. inside this, which is you're gonna get equal to, substitute first lah, make it easier. 3 cube minus with 9x square, 9x, substitute 3 inside, square, minus with 21 multiply x, you're gonna get 3 also, plus with 2, you got like this. Then you substitute. Okay, you're gonna get equal to negative 115. Okay, so by right you have a point here which is 3, negative 115. But then we don't know whether this point is actually inflection point or not. So how to find this inflection point? So it is inflection or not, we don't know ba? So this is why we have to do the second step where we differentiate the third time. Okay, so we find the third time here. So by right, we already got our d square y dx square. After we differentiate the two times, we get 6x minus 18. So you differentiate again 6x minus 18, you're gonna get 6x, we differentiate becomes 6. Negative 18 differentiate becomes 0. So your differentiation after the third time, you're gonna get equal to 6. Okay, the next step is, what we have to do is, I think I should go to the next side. So next step is substitute x is equal to 3 that you got from the first step just now, okay, into d cube y dx cube. So we have d cube y dx cube. We want to substitute x is equal to 3 inside ba? But then we have 6 here. Do we have x? We don't have x inside. So this is our after we substitute inside lah. And then you have to check this guy, is it equal to 0 or not? It's not equal to 0, right? So since it is not equal to 0, so the point, which point? This point, okay, 3 and 1, negative 115 is the inflection point. Okay, so in the future, if you have another question and then here you got equal to 0, right? By right, that point that you got from that question is not inflection point. So, but for this question, we got not equal to 0, ba? So, it is inflection point. Okay? So, here, I want to just do some, what should I say? Do some summarize lah. Do some summary for you for this question, for this topic, which is turning point and inflection point. So for turning point, I think better I use okay, no, I think it's okay lah. Cannot. Okay, it's okay. So here I will do just a summary of the difference between turning point and inflection point. Okay. Okay, so for the first step of turning point, what you guys have to do is find dy dx. And then let dy dx equal to 0. And then here you will find x. After you find x, substitute x into y. And then here you will get a point xy. After that, what you guys have to do is the second step, okay, the fourth step, you have to differentiate the second time. After you differentiate second time, you substitute x inside. Okay, and then once you substitute, you have to check if after you substitute, when you differentiate the second time, okay, if you substitute it is greater than 0, the point that you got here, xy is minimum. But then if you get less than 0, xy is maximum point. Okay, now we will go through the inflection point. So for inflection point, the first step a bit almost similar. It's just that here you have to find straight away. The first time you find d square y dx square, or differentiate 2 times. Okay, after you differentiate 2 times, you let become equal to 0, and then find x. After you find x, substitute x into y, and then you will get x, y, a point. Okay, once you get this point, we want to identify whether this point is inflection point or not, right? Okay, so what you guys have to do is find the differentiation for the third time. Do differentiation for the third time. Okay, and then after you find it, substitute x into it, into the d cube y dx cube. Okay, now in order for us to check, so what you guys have to do is, once you substitute, okay, if you substitute inside, okay, if it is not equal to 0, your xy is inflection. If it is equal to 0, then xy is not inflection point. That's it for the topic differentiation. Okay, so what I will do is I'll provide to you guys a form for you guys to fill in. So this is for your first tutorial session, since the lecture is on public holiday. Okay, so I'll provide to you the form, and then make sure you fill in, and then your submission, you have to answer a few questions, and then your submission will be considered as the attendance for the first tutorial session. Okay, that's it for the lecture. Okay, thank you and bye.